Hello, my name is John Whiteman, and I'm a member of Team Tricorder. The name of our project is called Headache Track and Predict. Our problem statement is as follows. A patient suffers from chronic headaches. So the doctor asks the patient to recall them during office visits. Unfortunately, the patient's memory is a bit fuzzy, so the doctor says, well, next time just write them down. The patient tries to do this, but the pain makes it unbearable. To save face, the patient hastily does a data dump in the waiting room, thus making this data just as unreliable as before. Our three main goals are simple. First, track the patient's headache episodes. Second, predict future episodes based on the tracked data. And third, build a simple FHIR-based framework that makes it easier for both the patient and doctor to do all of this. The tracking features include interact with the patient using hands-free voice technologies, record patient responses based on a small set of simple questions prepared by the doctor with the patient, collect other real-time data like time, location, and weather, and store the data in a database using standardized FHIR APIs. The prediction features will include retrieve and analyze the data from the FHIR database, build machine learning models to predict future headaches, visualize the data in an interactive, intuitive dashboard, and provide additional on-demand capabilities like add or delete observations and rebuild data models. Our team contributors include Mark, who's our FHIR developer, Easwer is our machine learning expert, Ramesh was program manager as well as packaging, Khan did the back-end work, and yours truly did the front-end work. Our schedule, as in the Gantt chart, came in 3 phases. The first phase, initial research and planning, this is where we did our proof of concept work. Phase 2, design initial implementation, this is where the work was done both in the front end and the back end, including the FHIR databases. Phase 3 is the integration and testing, where we put both ends together, tested, and also package and containerize for this demo. Regarding our project successes, well, we completed all tasks on time. We provided a fully tested, functional prototype that works in multiple environments using the FHIR API and database. We generated synthetic headache data to exercise our machine learning algorithms using R, and we received positive feedback so far from the TAs and others. Regarding deployment, well, it runs in multiple environments. The source code is maintained in GitHub. Installation is fully automated using Docker, and there's plenty of documentation to help customers get started. Regarding future plans, we want to go beyond a simple web application. We want to design or integrate as a portable, secure hardware device, and we'll use sensors to track body vitals and the environment. Also, HIPAA compliant for cloud storage, and potentially used with other medical ailment devices and data. Opportunities, both commercial and academic. The hardware device can be sold as a product, and the software can be open source with the FHIR APIs. Also, medical research for patients who opt in to use their data. Now it's time to do the demo. Let's authenticate. And we have a choice to record our headache session either by voice or keyboard. Let's choose voice.
Do you have a headache to record?
Yes.
When did it start?
Yesterday, noon.
Are you still feeling pain?
No.
When did it stop?
Now.
From a scale of 1 to 10, describe the pain severity.
10.
Do you have anything else to add?
Yes, I'm dizzy and feel like throwing up.
Thank you for the responses. Shall I repeat them back to you?
Yes, please.
Sure. Question 1. Do you have a headache to record? You responded, yes. Question 2. When did it start? You responded, yesterday noon. Question 3. Are you still feeling pain? You responded, no. Question 4. From a scale of 1 to 10, describe the pain severity. You responded, 10. Question 5. Do you have anything else to add? You responded, yes, I'm dizzy and feel like throwing up. All right, can I send your responses to your doctor now?
Yes.
Your responses have been sent to your doctor. Thank you.
So this data, this session, was sent back to the FHIR server. Now let's go to the dashboard and load all of our headache observations here. Now, as you know, this is synthetic data set, and this is the latest timestamp, and below that is the patient information, the health record. This on this side is a headache prediction, which is the next day, and it shows possible pain severity of 4. If we come down to the headache timeline, you'll see 2 colors. The one in green is the actual data, and if we click on it, we'll see the details of a specific observation. In fact, if we want, we can even delete it by doing this. Now the orange line indicates predicted values, and if we click on here, we can go up to 5 days as mentioned for any of these predictions. Now one of the nice features is that since we modified the data, we can request a rebuild of the machine learning model by doing this. So we send a request, it's a REST API, and if we look at here in the debug console, this is rebuild. And what rebuild is doing is calling the backend machine learning script, the R script, and we're going to see the output of that script right here, which means it's successful. Now, if we wanted to see the updated images that Easwer was talking about, they're automatically loaded here.
Hi, I'm Easwer Chinnadurai from Team Tricorders. My core area of focus in this project is the machine learning module. This machine learning module consists of 3 subtasks. The first one is to obtain the synthetic data. The second is to analyze the data that we have got to generate insights. And the third is to do prediction or forecasting based upon our analysis. To obtain synthetic data, we looked at the samples from Georgia Tech server, the synthetic data generator, and several samples from the internet. The key information that is required for this project is the observations regarding the headache episode a patient has, along with the severity of the headache. Data on other related factors like body mass index, blood pressure, temperature, chronic diseases would be of added value. All these samples had data on the related factors but not on the core information, which is the details on the headache episode. So I created our own data generator using R script. To do any meaningful analysis, we need some critical mass of observation. I have created data for 2 patients, a male and a female, 600 samples per patient, covering 3 years of information. All these data are generated randomly, picked from a normal distribution, using the range for the parameters from the samples that we analyzed. But specifically for the headache severity, which is our key parameter, I have introduced a bias to see when we analyze the data if it produces any interesting pattern. All these observations are fed into the Fire server, and when you click on the dashboard, it fetches this information from the Fire server and you can see the visualization for the same. Having obtained the required data, next we will do exploratory analysis to get more insight into it. First, we start with data cleansing to get rid of duplicates and outliers. Our synthetic data didn't have much outliers. Then convert the data from irregular to regular time series by adding missing dates with headache severity 0 and mean for numeric variables and mode for category variable. Then we can visualize observation data parameters, decomposition of features, trend analysis. In our application, click on View Exploratory Analysis to see this visualization. For the headache severity, we see a pattern of increase in severity and repetition yearly. For the remaining parameters, we see they are at a random with max frequency at the mean since we used normal distribution. Next, let's decompose the observations. Here, you see the seasonality pattern in the observation. Notice that the headache severity is low during winter, increases during spring and summer, and its peak at fall, and it repeats every year. That's the pure seasonality trend, and here is the randomness in that. These two put together, you see the trend in here. And below are some more trend details. We can see overall there is an increasing trend, and this one shows that during the weekend it is high, and during the weekday it's moderate. So the patient may be doing something different on the weekend, and on the yearly observation it again repeats low during winter and high during fall. These are some of the interesting insights that we get from analyzing the observation. This could help the service provider in classifying the headache type, diagnosing, and also providing appropriate care. Having obtained insight into the observation data, we use the same to predict future expected headache severity. I have leveraged Prophet package, which is an open source from Facebook that uses piecewise linear or logistics growth curve trend and predicted for the next 365 days. And I have also did the anomaly analysis. Here you can see for 365 days, and anomaly analysis. Huge variation would help trigger for deeper diagnosis for the patient